Hello guys, my name is Wilfrid and I'm a senior math tutor, and today I'll be covering 10 questions related to functions and algebra and also um, some graphing. So a little bit backstory upon myself. I graduated from a master with major in biochemistry and minor mathematics. And if you have any other problems with your math homework, calculus, chemistry, just submit them through OneClass and we'll get to them as soon as possible. And with that being said, let's get right into it. All right, so the first question reads, what is the value of the expression 2x squared plus 3x y minus 4y squared when x equals 2 and y equals negative 4? So even before I jump into this question, I want to describe what we're trying to do here. Okay, so this question gives us a function, and I'm going to label our function as z, and z is a function of two variables, x and y. And it is a function that maps x and y to a different value through this function. Okay, so if we were to think about it as having two pools of values, oops. So in our first pool here, we have our values of x and y. We call this our domain of function z of xy. Okay. Oops. Z of xy. Okay. So if we have a pool of values of xy, which we call our domain, and a pool of values called our range of z of xy, where there are values that are mapped of xy to z of xy, then our function here connects our two pools of values. Okay. So when they're giving us a value of x and y, such as x equals 2 and y equals negative 4, they want us to evaluate what this pair maps to in our range. So that's what we're going to do in this question here. Okay. So to evaluate your function, all you really need to do is plug in your values of x and plug in your value of y. So again, I'm going to write out our function here. So z of xy is equal to 2x squared plus 3 times xy minus 4y squared. So x equals 2 and y equals negative 4, and what does that equal to? So z of 2 and negative 4 is equal to 2 times 2 squared plus 3 times 2 times negative 4 minus 4 times negative 4 squared. Okay, and that's equal to 8 plus negative 24 minus 4 times 16, okay, which is 64. So that's equal to negative 16 minus 64, that's equal to 80, negative 80. Okay. Let me just check if this answer is correct, make sure my mental math is there. And yes, so the answer is negative 80, and that's how you evaluate your function of xy. In this case, you just plug it in and you simplify your expression until you have your answer here. So that means that z of 2 and negative 4 xy pair maps to negative 80 processed through this function, z of xy. Okay, so this solution is correct. And one more time, let me just illustrate through my diagram here. Okay, so if we had a value pair of 2 and negative 4, that means that the function z mapped 2 and negative 4 to a value negative 80. Okay. All right, moving along to the next question. The next question reads, find these expressions where a and b are vectors. Okay, so vectors are basically quantities with a direction and a magnitude. Okay, so the values that you see in a vector, so the regular notation for vectors are written like this. So let's say we have vector A. Okay, so vector A has an arrow sign noting that it is a vector, And that can be written out as a coordinate system where it's I, j, k with constants, or as a sum system like I plus j plus k. Okay, and you can have as many components as you want, and those components all contribute to the direction and the magnitude of the vector. Okay, so in this case, our vector A is equal to I plus 5j minus 2k. So the direction of this vector is noted by the vector being 1 unit in the I direction, plus 5 units in the j direction, and minus 2 units in the k direction. So if you were to have a axis planes with 3 different axes, you can really map out this vector for yourself. Okay. Another way to write this is writing it in the coordinate system, which is going to be 1, 5, and negative 2. Okay. So our second vector, vector b, likewise is going to be negative 4 units in the I direction, negative 1 unit in the j direction, and 5 units in the k direction. Okay, and these units are unspecified unless you want to specify them in a different way. And the coordinate system, they're going to be negative 4, negative 1, and 5. Okay, so another important equation that we need to know, or another important formula, is how to calculate the magnitude of this vector. Okay, so the magnitude of the vector is simply, and the notation for it is an absolute value sign around your vector, is going to be the square root of I squared plus j squared plus k squared. Okay, and we're talking about the magnitude of each of the components squared and then square rooted. So that is how we calculate the magnitude. Okay, so now that we have these two formulas in mind, we can now try to solve each of these expressions. Okay, so first we have our first expression is going to be vector A plus vector B. Okay, so when you're adding together vectors or when you're subtracting vectors, you have to add each of the components or subtract each component separately. You're not adding them all together at once. Okay, so when we're adding vector A plus vector B, what does this mean? So A plus B is going to look like something like this. Okay, so if we had vector A here, and that corresponds to I plus 5j minus 2k, we're going to add each of the components separately. Okay, we're not going to add them all together. We're going to add them separately. Okay, so we're going to do this, and we're going to put an addition sign, and we're going to add them. Okay, so I minus 4i is negative 3i. 5j minus j is 4j. And negative 2k plus 5k is going to be 3k. Okay, so the vector A plus B is going to be negative 3i plus 4j plus 3k. And let me just write this out in coordinate form just to keep the notation consistent. So that's going to be vector A plus vector B. Okay. So I'm just going to read it here. So that's the answer there. Okay, so the next one, we have 2 times vector A plus 3 times vector B. So when you're multiplying your vectors by constants, you're going to multiply each of your component by the constants that you have specified here. Okay, so in this case, we're going to first multiply our vectors by their respective constants, and then we're going to add them together. Okay, so we're looking at for 2a times plus 3b. Okay, so 2a is going to be equal to 2i plus 10j minus 4k. Okay, and 3b is going to equal negative 12i minus 3j plus 15k. And if we were to add this together, because that's what they want us to do, we would get negative 10i plus 7j plus 11k. Okay, so now writing this out here, we have negative 10i plus 7j plus 11j. Or in the coordinate system, we have negative 10, 7, and 11. Okay, cool. So now we're going to look at the magnitude of vector A, and like I said in our equation here, or our formula, this is how you calculate the magnitude of any vector. Okay, so for calculating the magnitude of A, we have to calculate the square roots of the squares of each component. So it's going to be 1 squared plus 5 squared plus negative 2 squared. Okay, so that's going to equal 1 plus 25 plus 4, and that equals 26 root of 30, and root of 30 is going to be that. Okay. That's the root of 30. Okay, cool. Now, the final question asks us to calculate the magnitude of A minus B. So, in vector mathematics, I guess you can say, you want to calculate the subtraction of the vectors before you calculate the magnitude. So that's what we're going to do. So first, we're going to calculate the subtraction of these two vectors first. Okay, so and on a side here, A minus B is going to equal, where's my two vectors? This guy is here. Okay, we're going to equal 5i plus 6j plus or minus 7k. Okay, so this is vector A minus vector B is going to be this respective vector itself. And then if you're going to square root that, we're going to have 5 squared plus 6 squared plus negative 7 squared. Okay, and that's equal to 25 plus 36 is 51 plus 49 is 110. 25 plus 36 is 51. No, 61 plus 49 is 110. Okay. So that means that the magnitude of vector A minus vector B is root 110. So this is how you do some of the vector calculations. It doesn't really account for the dot product or anything like that, but other than that, these solutions are correct. Okay. So these solutions are correct. Nice. Okay, moving on. All right. So the next question reads, how do you factor completely the parabola 3x squared plus 2x minus 1? So the junior tutor, they use the technique of grouping to satisfy this question here. We're going to use a technique I like to call the cross multiplication method to solve it. I'll also cover the method that the junior tutor used here. Okay, so in the cross multiplication method, you basically are trying to factor the standard form of a quadratic function, which is ax squared plus bx plus c, into dx plus e times fx plus g, okay, where d and f are factors of a, and e and g are factors of c, such that b is equal to d times g plus e times f. Okay, so we're going to need to find a pair of factors for A and a pair of factors of C such that this condition holds. Okay, now this might sound a little bit difficult at first, but in practice and in reality, it's actually kind of easy. Okay, so let me run through it with you guys with this example. So we want to factor 3x squared plus 2x minus 1. First thing we want to do is we want to make sure this is in standard form, which it is. So now we want to think of the factors of 3, right? The coefficient of a. Right, so the factors of 3, and we're going to include negative numbers here. So the factors of 3 are going to be 1 and 3 and negative 1 and 3. Negative 1 and negative 3, right? So those are the only pairs of factors here. And in this case, I'm going to think about using 3 and 1, okay, as the factors, okay? So a good check to make sure that these are actually the factors is you want to multiply these together, and if you get a coefficient a, then you're good to go. Okay, so now that we have found the factors of 3 and 1, we want to think about the factors of negative 1. Okay, so since it's a negative number, one of our factors has to be a negative, right? And the only factors of negative 1 are negative 1 and 1, right? So that's what we're going to write out here. Okay. Now, this is mostly a trial and error at this point, right? Because the next part of the process is to cross multiply these digits, okay? So what I mean by cross multiply is you're going to multiply 3 and 1 and 1 and negative 1. And you're going to add the products of those together. So if you cross multiply this, so 3 times 1 is 3, and 1 times negative 1 is negative 1. And if your sum or your difference here is equal to the middle coefficient, b, then you have found your pair of factors, which is going to be this and this. Okay, so the thing is that you can mess with or you can arrange the order of these factors differently, right? You can put 1 up here and 3 down here, and that will not produce the same answer, right? That will give you negative 2, right? So it is all really trial and error, right? Finding the pairs of factors that work is a trial and error, and also finding the right orientation of your factors is also a trial and error. Well, I will say this is that if you do enough practice with the cross multiplication method, this is actually a very easy method to integrate into actually factoring a lot of different quadratic functions. And if you're able to master this method, then you save yourself a lot of time just trying to factor different quadratic functions with different kinds of coefficients. Because sooner or later, you'll recognize the patterns. And especially with the simple quadratic functions like so, you can really just do this in your head. You can be like, okay, so the factors are 3, x and negative 1, and x plus 1. But in any case, we're going to keep moving on. So now we have on our factors, we can arrange it as so. And this is equal to 3x, so don't forget your x's, minus 1, and x plus 1. And from here, you can find your solutions to the quadratic function or your zeros. Okay, so that is one way that you guys can do it. So the other way is what the junior tutor did. They used a method called grouping. Okay, so the first thing that they did is a very clever method. So they broke up the middle coefficient of our function here. Okay, so we have our function 3x squared plus 2x minus 1. So they reasoned that they wanted to break up our middle coefficient. So they wrote it in a different way. So they wrote 3x squared plus 3x minus x minus 1. So this is the same thing as this. Instead, they wrote 2x as 3x minus x, which is a little bit redundant. But if you continue to move on, you'll see why they did it, right? So now they broke up these brackets, and they have 3x squared plus 3x minus x minus 1. So this still equals our original function here, okay? Now they grouped up these terms in a different manner. So they grouped up 3x squared and 3x by themselves, and they also grouped up x and 1. Okay, so they factored out negative 1. Okay, so here they're in this first term, they're going to factor out 3 and 3x. Okay, so they factor out 3x. What do they get in the bracket here? They get x plus 1. And here they factored out 1, and they have x plus 1. And this is why the term grouping comes along, because we grouped up our terms within our function in a different way. And by doing so, we have found that these terms have a common factor, which is x plus 1. And if they factor out x plus 1 here, what remains is 3x minus 1, which is exactly what we got through our cross multiplication method. This is another way that you guys can factor. Personally, I prefer the cross multiplication method because it makes more sense to me, and I'm very well practiced at it. But the grouping technique also works, and for specific functions, actually, for specific quadratic functions, especially for ones that have For polynomial functions with more than 3 terms, grouping is actually a very excellent technique of breaking down and factoring your function. So I'll leave it at that, and the solution is correct, of course, and you can move on. All right. All right, so the next question reads, the tables that are presented in the question represent 2 linear functions in a system. What is the solution to the system? All right, so the first thing that we need to do before we even find a solution to our linear equations is to figure out what our linear equations are. So they gave us a table of values, and that's all we really need, to be honest, to find our linear equations. And the second part is to find a solution to that system. So what they mean by finding the solution to the system, in another word, is to actually find the point of intersection between these 2 lines. So the point of intersection between these 2 lines could be, there could be 1 point of intersection, and there can be infinite, or there can be 0. But we first have to figure out what our line equations are. So as you may or may not know, the standard form for a line equation is y equals mx plus b, where m is the slope of the line and b is the intercept, y-intercept of the line. Okay, so we're going to use this standard equation of the line to try to find our linear equations. Okay, and another thing to keep in mind is that the slope of a linear equation is known as the rise over the run of the line. Okay. So the rise over the run of the line, and that can also be equated to y2 minus y1 and x2 minus x1, where x1 and y1 and x2, y2 are points on the line. Okay. So we're going to use these 2 equations to find our linear equations. Okay. So let's talk about our first line. So our first line I'm going to label as A. Okay. So first we're going to calculate the slope. Okay, so we're going to just use these first 2 points here. So -6 and -22 and -3 and -10. All right. So if we're using our slope equation here, -10. Okay, so let me label my points first, so it's not confusing here. So we're going to have x1, y1 be -6 and -22. We're going to have x2, y2 be -3 and -10. Okay. So plugging it into our equation here, we have -10 minus -22, and then we have -3 minus -6. Okay, so what does that give us? We have 12 divided by 3, okay, which is 4. So the slope of our first line, which is A, is going to be 4. So now we can plug it into our standard form. So now we have y equals 4x plus b. We need to find a y-intercept, so we're going to plug in 0 and 2. If we do that, we get whoops, this is the wrong one. So we plug in 0 and 2, we get 2 equals 4 times 0 plus b, and b is equal to 2. So therefore, our line is y equals 4x plus 2. Okay, simple enough. Let's move on to b. Okay, so it's kind of hard to see these values, so I'm going to try to zoom in. Okay, I can't. Let's see if I can read it. Okay, so they have 2 points here, so we're going to use it. So b, we're going to use the slope equation again, where x1 and y1 are -3 and -21, I believe, and where x2, y2 is 0 and -12. Okay, cool. So using our equation here, we're going to have -12 minus -21. We're going to have that 0 minus -3. And what we get 21 minus 12, which is 9 divided by 3. And we have the slope equal to 3. We plug this into our equation, which is y equals 3x plus b, and we plug in 0 and negative 12, and what we get negative 12 equals 3 times 0 plus b, so b equals negative 12. All right, now we have found our two lines. Okay, so therefore y is equal to 3x minus 12, and we can move on. Okay. So now we need to find the point of intersection between these two lines, and it's going to be a is equal to, I should write a as this, a is equal to 4x, y equals 4x plus 2, and b is equal to y equals 3x minus 12. Okay, so there's two different techniques we can use here. We can either use the elimination method of finding the solutions or the substitution. Since we have the y isolated, y variable to be isolated, we're going to use the substitution technique. Okay, so we're going to plug a into b. Okay, what does that mean? We're going to sub y equals 4x plus 2 into our b equation. And if we can do that, then we get 4x plus 2 equals 3x minus 12. And what do we get? If we isolate for x, so we move x to the left side and all our constants to the right side, we get this, and we have x equals negative 14. Okay, all right, so if x equals negative 14, then we plug x equals negative 14 into, let's say, a, and what we get y equals 4 times negative 14 plus 2, and that's equal to negative 64 plus 2, which is equal to negative 62. Therefore, solution to the system is negative 14 and negative 62. Okay? 4 times, oh, sorry. 4 times 14 is 56. No, got a little ahead of myself. Sorry. It's negative 56, so it's negative 54. And that equals to negative 54. Sorry about that. I got a little bit ahead of myself. Okay, cool. So this solution is correct. Good work. Okay. All right, moving on to question number 5. All right, so which equation is true for zeros of negative 6 and 2? Okay, so what are zeros, first of all? So we're going to talk again about the quadratic function. Okay, so our quadratic function can be written out in the standard form as such, where f of x is equal to ax squared plus bx plus c. Okay, so the quadratic function has a quadratic equation where, so the zeros, so if the zeros are x equals a and b, okay, then f of a equals f of b, which equals 0. Okay, so that's what it means by 0. So the zeros are basically the values of x, which makes our quadratic function equal to 0. So that's why we call them zeros. Other words that we use for it is solution, or x-intercept. Okay, so those are the other words that we use for zeros. Okay, so in this question itself, we're given options of 4 different quadratic functions, and we want to evaluate whether these zeros, whether these values of x are zeros for each of these functions. Okay, so the simplest way that we can do it is by plugging it into our function. Okay, I'll show you guys a different method. It's a really extraneous method, but it's a good way to practice your factoring. Okay. So let's look at a first. So let's plug in x equals negative 6. So our function here is 2x squared minus 16x plus 12. So let's plug in x equals -6 and 2. Okay, so if 2 times -6 squared minus 16 times -6 plus 12, what does that equal to? 36, 72 minus 96 plus 12. Okay, so that does not equal 0. We're not even going to evaluate that. All right. All right. So what about 2? So we have 2 times 2 squared minus 16 times 2 plus 12. That's equal to -28, -16. So that does not equal 0. Okay. 4 minus 32, 28. Okay. Yeah. So we now know that option A does not have zeros and -6 and 2. Okay, so let's work for option B again, and we're going to plug in. And then for option C and option D, I'll show you guys a different method. Okay, so option B is 2x squared plus 8x minus 24. So let's plug in x equals -6 and 2. Let's see what we get. So 2 times -6 squared plus 8 times -6 minus 24. I have a good feeling about this one. Maybe not. 72 plus 48 minus 48 minus 24. That equals 0. Okay, 72 minus 48 is 24. That equals 0. Okay, how about 2? 2 squared plus 8 times 2 minus 24. That is equal to 8 plus 16 minus 24. That equals 0. And therefore, for this quadratic function, its zeros are -6 and 2. Okay? All right, for C. Now we're going to use a different method, and we're going to use factoring to help solve this. Okay? So basically, by finding the factors of our function, it's very easy for us to identify the values of x that make our function equal to 0. Okay, so if we have 3x squared minus 4x minus 12, so we're going to use the cross multiplication method again. So factors of 3 are 3 and 1, and the factors of -12, let's use is this factorable with this method? 6, 2, use -2 and 6. No, that's not going to work. Use 3 and 4, maybe? I don't think this is factorable using the cross multiplication method. I don't believe it is. Yeah. So actually, now I'm thinking about it, it's not factorable using the cross multiplication method, and that's because the factors of this quadratic function are not whole numbers. They're not integers. They're instead probably rational numbers. So we're not really able to use the cross multiplication method here, unfortunately. So we'll just keep plugging it in into our function here. So we're going to plug in x equals -6 and 2. So if we were to do that, we have 3 times -6 squared minus 4 times -6 minus 12. Okay, and 36 times 3 is 1008, I believe. Times 3, yeah. Okay, and minus 24, or plus 24 minus 12. So this doesn't equal 0, obviously. Let me just check my math and make sure this is correct. 36 times 3 is 18, 9, 10. Yeah. Okay. And 2 squared minus 4 times 2 minus 12. That's equal to 12 minus 8 for -8, which is not equal to 0. Okay, so we figured out that x equals -6 or 2 are not zeros of this quadratic function. And finally, we have d. I don't believe this is factorable with the cross multiplication method again. I'm just looking at the factors already. I don't believe it is. I can take a look at it. 9, 4, 12, no. 6 and 6. No, it's not. Okay. And already looking at this, I already know that the values of x of -6 and 2 are not going to be the zeros. Okay, but we'll evaluate it anyway. So 3 times -6 squared plus 12 times -6 plus 36. That's going to be 108 minus 72 plus 36. Okay, so 108 minus 72 is 36. So that's, if this was -36, then this would be 0. That is not. Alas, it is not. Okay, and let's check 2, 2. So 3 times 2 squared plus 12 times 2 plus 36. And that's equal to 12 plus 24 plus 36. That's not equal to 0. Okay, so we have evaluated each of them, and we have figured out that option B is has a quadratic function whose zeros are -6 and 2. So I'm going to use this as an example to show you how the cross multiplication method can find either zeros. Okay, so going back to our question here, we have our function as 2x squared plus 8x minus 24. Okay, so let's think of the factors of 2 and -24. So the factors of 2 is 2 and 1, and the factors of -24 are, so there's a lot of different factors. We have 1 and 24, we have 2 and 12, we have 3 and 8, we have 4 and 6. In this case, we're going to use, what should we use here? We should use 4 and 6, I believe. So -4 and 6. Okay, so if we were to cross multiply this together, we get 12 minus 4, which is equal to 8. So we have found our factors here. And our factors are going to be, so 2x squared plus 8x minus 24 is also equal to 2x minus 4 times x minus 6, or plus 6. We can factor out the 2 here, so it's 2 times x minus 2 times x plus 6. So now that we've found our factor form, it's very easy for us to find the values of x that makes this quadratic function equal to 0, right? We just have to find this value of x that makes this bracket equal to 0 and the value of x that makes this bracket equal to 0, right? So x minus 2 is equal to 0 when x is equal to 2, because 2 minus 2 is equal to 0. Same thing with x plus 6. When x is equal to -6, this bracket is equal to 0. That means our zeros are 2 and -6. Right? So finding the factor form helps us to really easily identify what our zeros are, right? So this is an alternative method of answering this question. Instead of plugging in our zeros into our quadratic function and simplifying, all we really need to do is to find our factor form, and our zeros are just blatantly there, just staring at us in the face. So other than that, the solution is correct, and we can move on. Next one. Cool. All right, question number 6. All right, so which function out of all these functions here has a domain of x greater or equal to -11? All right, so all these functions follow the parent function of a square root function. So when we're talking about domain and ranges, as I mentioned before, so the domain is all the values of x or all the values of a function that define it. And what I mean by define it is that means that there is a legitimate value that is mapped to that function, to that value. And the legitimate value has to be a value of the real number line, okay? So in this case here, what I'm talking about for different I guess, family of functions is that they all have similar domains and ranges, okay? So for example, like our polynomial functions, all polynomial functions, unless there is a a general or a specific set of restrictions set upon them have a domain and range that is the whole real number set, right? The whole real number set is the domain and range. In case for our square root function, okay, so the parent function looks like this, where f of x is equal to the square root of x, and you can have different kinds of alterations around that. Its domain is going to be x belongs to all real values except x has to be greater or equal to 0. Okay, and the range of this function is going to be y belongs to all real values, but y has to be greater or equal to 0. Okay, so that's the domain and range of the square root function. Okay, and this is because the square root function cannot square root negative numbers. And because of that, there is a restriction upon its domain and range. Okay, so looking at our functions here, we have to evaluate each of the functions and find its domain and range. Okay, and if this domain is similar to this, then we have found our function that has the domain of x is greater or equal to negative 11. Okay, so in all of these functions, we have to ask a question. What values of x will make our square roots be a square root of a negative number? Because what values of x makes it a negative number means that that is a restriction upon its domain. So our first function is y equal to square root of x plus 11 plus 5. Okay, so we don't need to worry about this constant plus 5 out here. We just need to worry about what's inside the brackets. So what is going to make x plus 11 less than or equal to 0? Okay, so the values that are going to make it, sorry, let me make it that way. What are the values that will make x plus 11 greater than or equal to 0? Well, if we isolate for x, we're going to have x going to be greater or equal to 11, negative 11. So this is our domain right here. By finding this, the values of x that satisfies this inequality, we have found our domain. Therefore, the domain of this is going to be x such that x belongs to all real values, except that x has to be greater or equal to negative 11. Okay. All right. Let's do that for the next couple of functions here. So for b, we have y equals the square root of x minus 11 plus 5. So we ask ourselves the same question again. What values of x will make our square root negative? So what values of x will make this inequality true, right? So as long as this inequality is true, our function is defined, right? So if we isolate for x, we have x has to be greater or equal to 11, right? So if x is less than or equal to 11, so let's say x is 10, then this function is going to be a square root of a negative number, and we cannot evaluate it, and it's not defined, at least in the real number set. Okay, so because of that, our domain here is going to be x is such that x belongs to all real values, but x has to be greater or equal to 11. Okay, so let's quickly evaluate the last two functions here because they're kind of the same. So we have y equals the square root of x plus 5 minus 11, and the other one is going to be y is equal to the square root of x plus 5 plus 11. So you see here, we're not even considering these constants here because they don't really dictate our domain. But our question again is, what values of x are valid for the square root? And so we have to ask ourselves, what values of x makes this inequality true, where x plus 5 is greater or equal to 0, and we have found our answer, x is greater or equal to negative 5. So as long as x is greater or equal to negative 5, our function is defined, and our domain here is going to be d is equal to x such that x belongs to all real values, but x has to be greater or equal to negative 5. Okay, so going back to our question, we're trying to find the function that has a domain of x is greater or equal to negative 11. And we found it. Option A is our function. So this solution is correct. Good work. All right, moving along to question number 7. All right, so question number 7 is going back to the really, really big basics of mathematics here, okay? So it asks us, what are the steps in adding two rational expressions? Okay, so there's two cases of how you add rational expressions. And the first case is what all cases should be like. All right, so the first case is where, I guess I have to explain what a rational expression is first. So a rational expression is basically the ratio, right? That's where it gets its name, rational expression, of two different integers. Okay, so is the ratio of two different integers, and this is the notation for a rational expression. And so the terminology that I'll be referring to is the integer on the top of the divisional bracket here, or the horizontal line, is called the numerator. And the term at the bottom, or the integer, is called the denominator. Okay, so we have two different distinct cases, really not distinct. So the first case is a simple case, right? So whenever we're adding two rational expressions, we need to make sure that the denominator of both expressions are the same. So the first case is if the denominator are the same. Okay, if the denominators are the same, so if we have an expression such that we have a plus, I guess, expression b plus c plus expression b, c over b, then we have, all we have to do is just add the numerators together. Okay, so that's equal to a plus c over b. Okay, so an example, let me write an example here. So if we have, let's say, 1 over 2 plus 3 over 2, right? That will be equal to 1 plus 3 over 2, right? And we simplify, we get 4 over 2, and we know that 2 is a multiple of 4, or 4 is a multiple of 2, so we can simplify and we get 2. Okay, so that's the first case, right? So in all other cases, you want to attain the first case because that's how you add, right? So the second case is if the denominators are not the same. And this is multiples. Mostly all the cases that you encounter is going to be of this kind. Okay. So if the denominators are not the same, not the same. Okay. We have a little bit of a conundrum. Okay. Because let's say if we have the rational expression a over b plus c over d, right? So we need to make sure that these denominators are the same. So we need to first of all do something else to add these rational expressions together. And the thing that we need to do is to find the least common multiple of these two denominators. Okay. So what do I mean by least common multiple? Okay. Now, this is not the least common multiple rule, or the least common denominator rule is not really a rule per se. It's more of a guideline of how to add rational expressions together. If you really wanted to, you could find any amount of multiple that you wanted, and you can convert your denominator to that multiple. So let's talk about converting your rational expression first, and then I'll talk about why you want to find the least common multiple. Okay. So let's say that you've had a rational expression, let's say 5 over 4. Okay, so first of all, what is a multiple of 4, right? So when we talk about multiples of 4, we're talking about 4, 8, 12, 16, right? So that's what we call multiples, right? What we mean by multiples is that they are basically groupings of 4. Okay, so 4 is a multiple of one group, right? So there's one group of 4. And then 8 is two groups of 4. So we call that a multiple of 4. Okay, so how it so happens is that numbers can have the same multiples of different numbers. Okay, so for example, and this is getting to really basic math. Okay, so if you have 2 and 4, okay, as our numbers here, okay, 8 can be written as a multiple, as two multiples of 4, right? And if you want, it could be two multiples of 4 apples. I don't know how basic we want to go. Or it could also be 4 multiples of 2, right? So each number can be different multiples of different numbers. That's what I mean by that, okay? So going back to our question, our example here of converting our denominators, right? So if we wanted to convert 4 to be, I guess, 16, right? So if you wanted to be converting 4 to 16, right? We have to convert our numerator, right? Or else that will not be an equivalent expression. So let's say that we wanted to convert our denominator to 16, right? So how do we convert 4 to 16? We multiply 4 by 4, right? So if we want to multiply 4 by 4 to get 16, then you have to multiply your numerator by the same, right? So we have to multiply 5 by 4. So this is an equivalent expression to 5 over 4, which is 20 over 16. Okay, let's do another one. So we have 5 over 4, and we want to convert it to, let's say, 32, the denominator. Okay, so if we want to convert it to 32, for example, then how do we convert the numerator? Well, 4 to 32 is 4 times 8 is equal to 32. So we have to multiply our numerator by 8, which is going to be 40 over 32. So these are equivalent rational expressions. Okay, so now that we have talked about how do we convert denominators and convert the rational expression to be equivalent, we can now talk about finding the least common multiple and converting our rational expressions. Okay, so in our example here, we're going to use 1 over 2 and 1 over 3. Okay, so we need to find a least common multiple of 2 and 3. Okay, so we're going to find the least common multiple of 2 and 3. Okay, so let's list out some multiples of 2. So the multiples of 2 are 4, right? So 4 is 2 multiples of 2, 6, which is 3 multiples of 2, 8, what am I doing? 10, 12, 14, 16, 18. Okay, so I just listed out different multiples of 2, right? So 2 multiples of 2, 3 multiples of 2, 4 multiples of 2, 5 multiples of 2. All right, cool. Let's list out some multiples of 3. Well, we have 2 multiples of 3, which is 6, 9, 12, 15, 18, 21. Okay, so I just listed out some multiples of 3. Okay, so let's find the common multiples between these, right? So we have a few common multiples. We have 12, we have 6, right? And we have 18, okay? So why we want to find the least common multiple is that we want to convert our expressions into more simpler expressions. So we could use a multiple of 18 in this case here, but we'll have to simplify our final expression a little bit more, and it'll take a lot more work, right? So if we use the least common multiple, our simplifying and our calculations are a lot more simpler, basically. That's why we use the least common multiple. You can use any multiple that you want, but using the least common multiple is the most efficient way of calculating the addition of rational expressions. So here, our least common multiple is 6, so we're going to use that. So like I said, in converting our expressions, rational expressions to other equivalent expressions, we have to multiply our numerator and denominator by the same factor. Okay, so to get 1 over 2 to be 1 over 6, we have to multiply the numerator by 3. Okay, and in the same way, to get 1 over 3 to something over 6, we have to multiply our numerator by 2. So these are equivalent expressions for 1 over 2, which is 3 over 6, and 1 over 3, which is equal to 2 over 6. So now 1 over 2 plus 1 over 3 can be written as 3 over 6 plus 2 over 6. And now we have gone back to our first case, and our first case tells us that the addition of two rational expressions with the same denominator is equal to 3 plus 2 divided by 6, which is equal to 5 over 6. So that is how you add two rational expressions where the denominators are the same and the denominators are not the same. Okay, so this solution is correct, or this explanation is correct. Nice job. Cool. All right, question number 8. All right, evaluate the logarithm without using a calculator, okay? So we're going to use a few properties of the logarithm to help us solve this, okay? So the first property of the logarithm, I guess, is that the log of base, let's say b, of argument b is also equal to 1. Okay, that's the first property we're going to use. The second property that we're going to use is the log base of b of, let's say, argument a with power of x. So this argument a is power to x is also equal to x times log of base b of argument a. Finally, we're going to use a property of exponentials or powers is that let's say that we have a x to the power of negative b, right? That's also equal to 1 over x to the power of b. Okay, so these are the properties of exponentials and logarithms that we're going to use to solve our question here. Okay, so we want to evaluate this logarithm without using a calculator. So y is equal to log of base 6 of 1 over 36. So the first thing that we're going to do is that we are going to use this property of exponential functions, right? So we know that 1 over 36 can also be written as 6 to the power of negative 2, because 1 over 36 is also 1 over 6 to the power of 2, and that is also equal to log of base 6 of 6 to the power of negative 2. Next, we're going to use this property, which states that we can move exponents down to be constant multiplying the logarithmic expression, right? So if we do that, we get log of base 6 of 6 times negative 2. And finally, we know that the log of a base of with the same argument is equal to 1, and we have 2 times negative 1, and y is equal to negative 2. So by using the properties of logarithms and exponential function, we're able to find our expression and simplify it without using a calculator. So this solution is correct. Nice. Oh. All right. So the next question asks us is how to graph the line y equals 4 and negative 3x. Okay, so there are mainly two ways of graphing a line. The first way is to look at the slope of the line and evaluate the line at each point and graph the line. The other point is much more simple. All we have to do is define 2 points of the line and then draw a line through it. Okay, so y equals 4 minus 3x. So usually the points of the line that I like to pick, and you can pick any point on the line, is I like to find the x-intercept and the y-intercept. Okay, so the y-intercept of the function is where the graph intercepts the y-axis, and the x-intercept of the function is where the graph intercepts the x-axis. So to find the y-intercept, we have to set x to be equal to 0. Okay, so if x is equal to 0, y is equal to 4 minus 3 times 0, and y is equal to 4. So our y-intercept is 0 and 4. Okay, for x-intercept, we're going to set y equal to 0 because when the graph intercepts the x-axis, our y value is also equal to 0. Right? So if y is equal to 0, we have 4 minus 3x, and we have negative 4 equals negative 3x, and we have x equals 4 over 3, and that means that x-int is 4 over 3 and 0. So now that we have our points, we have to draw an axis here. So let's do this axis real quick. Okay, so now we label our points on the axis, on the lines. Right, so 0 and 4 will be around if 1, 2, 3, 4, that's over here. And 4 over 3 and 0, if we have 1, 2, 3, 4, 4 over 3 and 0 is over here. So this is 4 over 3 and 0, and this is 0 and 4. So if we're to draw a line, and excuse my line drawing, we'll have a line that goes like this. Okay, move it down a bit. Okay, my line is really not, okay, that's the closest I can get. So that's our line. Okay, so with 2 points, all you have to do is find 2 points of the line and then graph them and then draw a line through it. And that's how you graph your line. And if you want to double check, you know your line has a negative slope, so it should be upward slope towards the negative direction. And you know the y-intercept is 0 and 4, which is right there, so this is the correct line. Okay, so this solution is correct. All right, finally, moving on to the last question of the day. How do you solve x squared minus 2x plus 4 using the quadratic formula? So when they're asking us to solve it, they're asking us to find the zeros, and I describe what the zeros are. It makes this quadratic function equal to 0, right? So they're asking us for the values of x, which makes this quadratic equal to 0. And the quadratic formula is mainly reserved for when you cannot factor. So when you cannot factor, that means that you need to use a quadratic formula. In most cases, you can use it in general, but it's a lot of computation and a lot of people stray away from it. And the quadratic formula is going to be negative b plus or minus b squared minus 4ac divided by 2a, where ax squared plus bx plus c. Okay? So a, b, and c are the coefficients, and you just need to plug them in, and you'll find your values of x, which satisfy this quadratic function or equation. Okay, so using this formula here, we have negative 2 plus or minus negative 2 squared minus 4 times 1 times 4 divided by 2 times 1. Okay, if we simplify this, we get 2 plus or minus the square root of 4 times negative 16, which is negative 12, and we have 2. Okay, so at this point of the formula here, we see here that we have a square root of negative 12. And that brings us a lot of worry because, like in the previous question here, we said that the square root of a negative number is not defined. And that is partially true because the square root of a negative number is not defined on the real number value set. Okay, but mathematicians have avoided this and have circumvented this problem by setting up a new imaginary number set, and we call it I. So I is basically equal to the root of negative 1, and that helps us to circumvent what we have here. So we have now know that our solutions to this quadratic equation is going to be imaginary, or a complex number set. Okay, so we're going to use a complex number set to evaluate our function here. And so the negative root of 12 is, the root of negative 12 is also equal to 2i times root 3. And now we can move on with our evaluation here. So we're going to have 1 plus or minus I root 3, and the values of x that satisfy our quadratic equation here are going to be 1 plus I root 3 and 1 minus I root 3. Okay, and how I got 2I root 3, if I want to show it here. So negative 12 can also be written as root of negative 1 times the root of 12. And root of negative 1 is equal to I, and the root of 12 can be written as radical form, which is going to be 2 times root 3. So that's how I got 2i times root 3, and then I found our zeros. And if you were to plug this into our quadratic function, and I'm not going to do that here, you'll figure out that these values actually make our quadratic function equal to 0. Okay, so this solution is correct. Good work. All right. So that wraps up today's lesson on functions and algebra. If you have any other questions related to calculus or functions or algebra or even chemistry, just submit them to OneClass and we'll get to them as soon as possible. But other than that, I wish you guys a good night and I hope you guys learned something. Bye, guys.